Dear students, I am Dilavar Basha, Assistant Professor of Degree Department RMKCET. I am very happy to give a video lecture on electrical measurement for the Department of CSC first year. Before entering into the respective topics, I want to give the overview of this fifth unit. This fifth unit is totally categorized into two different categories. So category number one, it covers various operation of meters and the basic phenomenon of the meters. So we have topics like pole and magnet, moving coil, moving ion, and various top definitions, and energy meters, watt meters, the construction, the working, the derivations. So these topics come under the first category. And the second category we have transducers. So various types of transducers, their applications, their working principles, and how each differs, and their classifications, their characteristics, how its behaviors. So these topics will come under the second categories, including CRO. Now, in these video sessions, I'm going to cover this for four different types of transducers. Four different types of transducers: RTD, thermoelectric transducers, piezoelectric transducers, and LDR. So four different types of transducers I'm going to cover. Before entering to this RTD, the understanding of a basic of a transducer is very important. So because the basic phenomena is common for all the type of transducers, if we understand the basic phenomena, so it is very easy to understand all the types of transducers. So let us see that what is meant by transducer first. Dear students, before looking at the RTD, first of all we should know what is the basic phenomena of a transducers. For any type of transducers, it works on a basic principles. So you should know first what is meant by transducers. A transducer is a device which converts a physical quantity into the proportional electrical signal, and that is called a transducers. That means that any physical quantity means it may be a temperature, it may be pressure, or it may be a length, or it may be distance. So these are the physical quantities we are seeing in day-to-day life. If that physical quantity, if it is converted into proportional electrical signal means what? It may be a voltage, frequencies, or it may be a current. Sometimes it is in the value of a resistance. So these are the electrical parameters. We already know these electrical parameters. So if this physical quantity is converted into corresponding electrical signals, that means that device is called as a transducers. So this electrical signal produced may be a voltage, it may be a current, or it may be frequencies. Now, in this transducers, if you see the internal block of the transducer, it consists of two blocks. One is called sensing element, another one is called transduction element. What the sensing element doing is, the sensing element is a primary element where we are going to sense the physical quantities. That means the primary informations, whether it is a temperature or pressure, that information has been sensed by this sensing unit, and then this information is given to this transduction element. This transduction element will get the input from a sensing element, that is a non-electrical quantity. That is a non-electrical quantity will be given as an input to the sensing element. So it will sense whether it is a temperature or is a pressure or whatever may be the non-electrical quantity. It is given to the transduction element. Transduction element convert this sensing element into the corresponding electrical signals. So these two blocks will form the transducers. So now we are going to see what is meant by resistance, temperature, detectors. So it is one of the type of transducers. Already we have seen the basic phenomenon of a transducer. It is used to convert one form of signal into another form of signals. So now the one form of signal, that is input signal, is always a non-electrical quantity for any type of transducers. Even in the case of this resistant temperature transducers, the non-electrical quantity where this transducer is going to measure is a temperature. The temperature is the one which will be given as an input to these transducers, and output for the transducers we will get as a resistance. So RTDs use a specific type of a metal that depending on the resistance measure in the metals. So we can see that the specific type of metals. So every metal having its own resistance. So if we maintain a particular temperature, and the resistance will maintain a particular value. That means we have to choose a metal in such a way which should depends on the temperature. If the temperature varies, automatically the resistance value also should varies. So that kind of material has been chosen for RTD. Now we are going to see how the RTD is going to work. So already we have discussed in the previous slide that the RTD is nothing but it is a transducer which is mainly convert the temperature into the corresponding resistance. So it is based on the correlation between the metal temperature and the resistance. So if the metal temperature is going to be increases, corresponding to the resistance is going to be increases. That means that it's not metal temperature, it is the input quantity. The input quantity will be the temperature. If the input quantity of the temperature where the metal is going to be fixed, so the temperature has been increases, based on the resistance also is going to be increases. The second point, if you see that as the temperature of the metal increases, the metal resistance to the flow of electricity is also increases. That means that we have two categories. That means if a temperature increases, the resistance of a metal should increases. It is called as a positive temperature of coefficient. So some metals will be having a negative temperature of coefficient. So that kind of metals we are not choosing for RTD. Each metal has a certain resistance measurement at different temperatures. So we can see commonly we are using metals like platinum, nickel or copper. So if the temperature is the same, suppose for example, if the temperature is 100 degrees Celsius, and for 100 degrees Celsius the platinum resistance is going to be vary, and the nickel resistance is going to vary, and the copper resistance is going to vary. So the resistance value is not same for all the metals for a common temperatures. So based on the resistance that is measured in a given type of material, we can determine what is the temperature is. So if I am getting a resistance value for a particular temperature, for example, if my temperature is 0 degrees Celsius, I am getting a resistance value is 100 ohms. If I am getting a resistance value as 150 ohms now, that means that obviously my temperature is increased, because when the temperature rises, automatically the resistance also will get increases. So on knowing the value of a resistance, we can able to judge that what is the value of a temperature. Now we are going to see constructions and types of RTD. Looking at the constructions of this RTD, we have various parts like insulators, non-inductive platinum element, stainless steel shell, leads, hematic seals. So this is the portion where the RTD is going to place to measure the temperatures, and corresponding temperature is going to convert it into the resistance. So this is the place where the platinum also has been placed. This RTD has been used as a thermometer also. So thermometer, we know that it is used to measure the human body temperatures. So whenever the human body temperatures varies, automatically the resistance of the platinum is also going to varies. So whenever it varies, this resistance is having a leads. This leads has been connected to that external circuit. So suppose for example, if the temperature has been measured corresponding any unknown temperature, corresponding resistance we are getting 100 ohms. For example, if this 100 ohms value will be get across the leads, this 100 ohms we can use for some other external circuits. Now apart from that, we have a protective outer core of this RTD. We have insulators, we have a stainless steel shell, and we have a non-inductive platinum elements. This mainly we have to avoid this corrosion of the resistive element. Usually elements are enclosed in a protective tube of glass. Depending on the range of temperature and the nature of the fluid whose temperature is to be measured. So the tube is totally evacuated and sealed or filled with air or any other inert gas and kept around atmospheric pressure in some cases at high pressures. Now apart from that, if you look at the types of RTD that is normally has been preferred based on applications. So where we are going to place, this is a rod type. You can see that suppose if we want to measure the temperature, if you want to convert the temperature into the corresponding resistance in a running fluid in industrial purpose. So suppose if you have a fluid, if you want to convert if you want to measure the temperatures, and the temperature based on temperature values will be get the corresponding resistance values. So we can use this rod. There is a wound RTD element. So you can see the platinum wire has been wounded and has been fixed in this wire wound element. So this is the one of the type, and you can see one more type is a thin film RTD element. So we can use this kind of structure also to convert the temperature into the corresponding resistance values. Now we are going to see the various metals properties. So already we have discussed in the previous slides that we are using a different kind of metals which is having the temperature coefficient as a positive. So whenever the temperature increases, automatically the resistance also should increase. So when we look at this, all these four metals, each will be having the different properties and different operating temperature ranges and melting point also is going to varies. So let's start from the platinum. So platinum will be having the temperature coefficient as 0.39 and the temperature range is minus 260 to 110 and the melting point is 1773 degrees Celsius. Similarly for copper is also having the resistant temperature coefficient 0.39, operating range is 0 to 180 degrees Celsius and the melting point is 1083. Nickel is the resistance temperature coefficient is 0.62, a little bit higher, and temperature range is minus 220 to 300 and the melting point is 1435 degrees Celsius. The last one is the tungsten, is less preferable and resistant temperature coefficient is 0.45 and the temperature range is minus 200 to 1000 and the melting point is 3370. So all these four types, the first three has been given the more preference. In these three also the most preferable used metal is the platinum. The first category is come to the platinum and next to that platinum we are preferring nickel. These two are the one we are mostly preferring for RTDs. Now let us compare this performance of all the three materials excluding tungsten. So these characteristics of these metals drawn between the resistance of the RTD element and the temperature of the RTD element. So if you look at the copper characteristics, it is completely linear. That means if the temperature is very increasing, corresponding resistance also will get increasing. So it is a drawback of the copper. So if we are choosing higher temperatures, so the copper resistance value will get more high. So there is a preferable, practically it not preferable. Now look at the nickel characteristics. Nickel has been most preferable if the resistance ranges we are getting as between 100 to 450 ohms. So we can prefer the nickel. So more than 450 ohms, if the resistance value is increasing, so the nickel is not preferred. But the most preferable and stable metal has been chosen for RTD is a platinum because it is having the stabilized waveforms even though the temperature has been increases. So the resistance is not that much sudden rise. We are getting, you can see the graph here, graphical representation. It is a smooth variation of this metal compared to this nickel and the coppers. Now we can find out the resistance of these metals by using the general formulas, that is R is equal to R reference into 1 plus alpha into T minus T reference. So R reference is a reference resistance at the temperature 0 or 20 degrees Celsius. Sometimes it may be taken as a reference for 20 or sometimes it may be taken for 0 degrees Celsius. So that is your reference temperature, reference resistance. It will be vary for metal to metal. Now this T is the unknown temperatures that is going to be measured and the reference temperature is already that 0 or 20. Corresponding this temperature, if it varies, automatically from this value we have to subtract this T reference and multiply this alpha. Alpha is nothing but the resistance temperature coefficient. So alpha is also constant and the T reference also constant and R reference also constant. So variable parameters only is a T. So T is the conductor temperature in degrees Celsius. So if you simplify all these values and we will get the corresponding resistance of the metals. Now we are going to end the part 1 session of RTD on seeing these advantages and disadvantages. Let us see what are the advantages we have for the RTD. They can provide a very high level of accuracy. So whatever the temperature varies, the temperature varies from 10 degree to 20 degree, correspondingly resistance also will get varied, so we will get a very high accurate values and we will get various operating ranges. If the temperature also will be vary from 100 to 300 or 200 to 400, based on that we can design RTDs also. Now they are often used in situations where the temperature measurement is required. So already we have discussed in the previous slides that in industrial applications we need to measure the temperature of the various liquids, and there also we can dip this raw type of RTD, and that RTD will measure the variation of the temperatures, convert into corresponding resistance. So we have various situations we will require to measure the temperatures and to convert the temperature into corresponding resistance. So these are the few advantages of RTD, and apart from that we have some drawbacks also. This RTD cannot be used if the temperature goes more than 660 degrees Celsius, and also the RTD not preferred for if the temperature is very low. So it having certain range, the RTD can be used only in between. If the temperature having 100 to 600 degrees Celsius, we can go for RTD, and the corresponding temperature will be converted into resistance.